Atoms contain charge. Atoms contain electrons, which are negatively charged, and protons, which are positively charged. And most atoms also contain neutrons, which are neutral in charge. Electrons are attracted to the positively charged protons, and the nucleus itself is positively charged. And so electrons tend to be attracted to the nucleus because of the opposite charges. But electrons are also oppositely charged, so they tend to repel each other and form orbitals. The protons are repelled by each other, and it is surprising to realize that the protons are found in a very dense, very tiny, in relation to the atom, package called the nucleus. This picture shows the nucleus very much out of proportion. If it were drawn to scale, the nucleus would be a tiny speck that we could not see on the screen. So how is it possible that multiple positive charges can be pushed together so closely and not repel each other and fly apart? Well, physicists describe this binding force that holds them together as the strong force. Another way to consider it is that maybe the nucleus becomes a single entity. No longer is it individual protons, but they coalesce into a single charge. Nonetheless, under some circumstances, the positively charged protons can become repulsive. In fact, some elements are unstable. Some elements have unstable nuclei. Here's an example of the element plutonium and the element uranium. Plutonium and uranium have different numbers of protons. Plutonium has 94 protons and uranium has 92. Sometimes plutonium will lose 2 of its protons along with 2 of its neutrons. This is called an alpha particle, and that's actually the nucleus of helium. When this occurs, the plutonium loses 2 of its protons and it becomes uranium, which has 92 protons. And so it's an electrical phenomenon that occurs here. The repulsion of the alpha particle, which is positively charged, from the nucleus, once it escapes it, repels it and pushes it away at a fairly large amount of energy. Although alpha particles are quite massive, because they really are helium nuclei, they can be stopped relatively easily by a piece of paper, for example. If you put plutonium in a closed container and leave it there for a long time, helium will slowly build up, because that's really what alpha particles are. Beta decay is another example of what we call radioactivity. Radioactivity is the emission of particles or waves, such as gamma rays, from the nucleus of atoms. In this case, palladium-230 releases an electron. Actually, it's an anti-electron, or often called a positron. And it is repelled by the positively charged nucleus and escapes. At the same time, a tiny particle called a neutrino is released, and in this circumstance, a proton is converted into a neutron. And so we see that palladium-91 becomes thorium-90. And there has been a transmutation again, and an emission of energy. This is called beta decay, a kind of radioactivity. Beta decay can be stopped by a piece of wood, or maybe a book or something of that thickness. It's a little more penetrating than alpha particles, and as a result, some more dangerous as well. at least if it is outside your body. Either one, if it's inside your body, is very bad. Gamma rays are a type of light, a very high energy photon of radiation that is not charged like protons or electrons, and so it's not affected by electric charge. But what's believed to happen in some nuclei is that the nuclei has different energy states or arrangements of charge. And what can happen is a nuclei of, say, plutonium-240 can rearrange its charges internally and release a little bit of energy in the form of a gamma ray, which is a high energy electromagnetic wave that's very penetrating. It can go through a fairly thick piece of dense metal, such as lead. It takes lead to stop it, or some other piece of dense metal, or a lot of earth. Gamma rays are very dangerous. Fortunately, there are not very many of them around us most of the time, although sometimes they come from the sun and other places in outer space, and some of the elements and materials around us emit small amounts of them. Many times a gamma ray will pass right through your body without really doing much. Other times, if they do hit something in your body, such as a cell, a molecule in a cell, they can destroy the bindings between the atoms and damage chemical linkages, such as in DNA. Another type of radioactivity is where nuclei of atoms split into parts. Uranium does this. Uranium-235, if it absorbs a neutron from some place, will break apart, and it will break into two new nuclei. In this case, we have barium-141 and krypton-92. So a transmutation occurs. Uranium forms two new elements, barium and krypton. And in the process, more neutrons are released or let go of from the nucleus. These neutrons can then go out and cause what's known as a chain reaction. And so one uranium atom fissions or breaks apart, releasing neutrons which then go out and hit other nuclei of other uranium atoms, in turn releasing more neutrons. Now, if this process is moderated or slowed down so that it's under control, we have what's known as a fission reactor. It releases a great deal of energy, but it's under control. It makes heat, and it can be used to power a power station. A nuclear power station uses uranium fissioning under control to create large amounts of heat, which generates steam to turn a turbine and a generator. The steam is recondensed again and recycled through the system. And so we have a way of generating power from the release of energy from the atom. If we allow the energy to be released very quickly, we can have an explosion, which is the basis of the atom bomb. Well, this discussion on charge ends with a picture of a sign, and I think this is appropriate because this illustrates the flow of current. A neon sign is a tube containing a gas, usually neon or argon, noble gases they're called. These gases, when an electric current passes through them, they emit light. And so here we have a power supply. We see wires, and we see a circuit, and the electricity is flowing through this circuit and back to the power supply again. Neon and argon and helium are examples of elements that like to hold on to their electrons very strongly. So if we energize the electrons sufficiently to knock them out, those atoms are most happy to get them back, and they will grab them back. And when they do so, they emit light, because the electrons go from a higher energy to a lower energy state. and that releases photons of light. So gases like this are used in many different lighting sources. Fluorescent lights also work by the same principle.